We're going to be focusing on sets, and it would be helpful to know what a function is when we're talking about sets. So when I think about functions, I think about a vending machine, because when I go to the vending machine and I push a button, it gives me out a snack that's in that place. So, let's say I want peanut M&Ms, one of my favorite treats. Let's say that button is B2. If I push B2, it's going to give me out the peanut M&Ms that are in the B2 slot. Okay? Now let's say that's a function. Let's say I push B2 and it goes to Cheetos at A5. I'm going to be outraged because that's not what I wanted. That's not where the button was supposed to take me. So that would not be a function. A function is when every input has its own output. When you push that button on the vending machine, it's going to go to a certain spot. Now, it's very possible that multiple spots in the vending machine have the same item. That's fine. That's a possibility. It's also kind of like calling someone. When I dial a phone number, it's going to take me to that person's phone. Now, different people could answer the phone, but that's still a function. We want to think about one input going to an output. There are many ways to think about a function because we could look at it algebraically so it could be in function notation. We could have, y equals 3x plus 2. That's a linear function. So graphically, something like this. I could have, it doesn't have to say y equals, we could also have f of x, h of x, g of x, any of those are fine. It could be a quadratic or a square root function. Any of those are okay. And it doesn't even have to be like a set function that we are familiar with. It could be, some sort of, polynomial with a, kind of like a wavy situation. Any of these would be functions. When you look at the graph, these are all passing the vertical line test. So if I were to take my pen and drag it across the screen, the function's never going to touch my pen more than once at a time. I could even go through and draw like a bunch of vertical lines. I'm only ever touching the pen, that line, once. Okay? So let's look at a set of points. When I'm plugging in numbers into these functions, it's going to create a set. So it's going to be several points, and I can make as many as I want. It could also look like a table of numbers. So if I plug in a number into this function, like 1, then I'm going to get out a number 5. And I could keep doing that. Over here, I have some separate sets that have nothing to do with those, just to give you an idea of what sets of numbers could look like. These are 2 different ones. So you'll see that each input, I'm plugging in 3, I'm getting out 5. I'm plugging in 2, I'm getting out 1. Plugging in -1, I'm getting out 0. That is a function. This one is a little different. You'll notice that you'll see 6 twice. And this is actually still a function. This is okay because what's happening is I'm plugging in 2 different numbers and they're going to the same place. That is okay. Think about the function like y equals x squared. I can plug in 5 and get out 25. But I could plug in -5 and still get out 25. That is a function. It's okay to have the repetition in y. If I'm pushing, 2 different buttons on the vending machine and I'm getting out the same item, okay? Now, if I have a mapping visually, this could obviously be a function. Each number is going, each input has a different output. Now, it could also be a function if, this is going here, whatever. Still, I still have each input having an output. This is even still a function. If I plug in 2 and 3 and I'm getting out 4, that is okay. It is okay for two different x values to have out the same y value, because what that means on the graph is that, I'm plugging in 2 and I'm getting out 4. I'm plugging in 3 and I'm still getting out 4. That's fine. That just means that part of the graph is a straight horizontal line. Let's look at some things that would not be functions. So these are not functions. So these are some common ones. So if you see like y squared here and here, the reason y squared is a problem is because you're going to have to take the square root, and that's going to give you that plus or minus situation, which is going to create this kind of sideways U shape if it's the square root function. This is actually the equation of a circle. So we really don't want y to have an even power. And this is also another one right here. Because if we have x equals 3, that is a vertical line. None of these are going to pass that vertical line test because you're going to be touching the function multiple times. And even if I have a straight up and down line, I'm touching it infinitely many times. So watch out for things that have that repetition in x. If I'm plugging in, with this function, I'm plugging in an x value and I'm getting out this negative number, but then I'm also getting out this positive number. That is what we don't want. We don't want our one x input going to two different places. We don't want to push the button on the vending machine and one time it's going to the Cheetos and one time it's going to the peanut M&Ms. If we look at a set of numbers, again, you'll see that the x's are giving me out two different numbers. That is what we do not want. Pretty much everything else is going to be a function. It's going to be helpful to know how to evaluate a function. When we say evaluate, we are looking at what that value is for the y value when we are plugging in the x value. So I have a function here, f of x, and this is my x value. All I'm going to do is substitute x or -4 everywhere I see an x, and then I'm going to work it out. So that would be -12 minus 3. So the answer is -15. That means that when I go onto the graph and find -4 on the x-axis, when I plug that in, I'm getting out an output of -15. I could write this as a coordinate point, plugging in -4, getting out -15. This is an x, and my output is the y. We could even do this for a quadratic function or a square root function, something with an exponential, anything. All we are doing is we are inserting this value in the function wherever we see it, and we are just working this out and getting an answer. We could even evaluate with a graph, because all we are given is an x value and we want to find that y value. So if I have a graph, I'm going to find that x value, -6, and now I'm getting out my y value of -3. So when you are evaluating, you are given an x value and you're trying to find the y value. That's pretty much the first part of sets and functions. We'll get into a little bit more next week. Let me know if you have any questions.